Hey guys, we're going to look at another example in this video where we have three equations with three unknowns, and we're going to try to solve the system of equations using elimination. So let's jump right into it, and as always, let me know if you have any questions as we go along there in the comments. All right, so we're going to, in this video, try to eliminate the y's first of all. So we're going to take those first two equations and try to eliminate the y's. And then I think we're going to take the first equation and the last equation and try to eliminate the y's. So for the first two equations, we see if we multiply that first equation by 3, then the y's will cancel when we add the first and second equation. So let's multiply that whole first equation by 3. So we'll get 3x plus 3y minus 3z equals negative 27. Okay, and then we'll rewrite the second equation, which is just 2x minus 3y plus 2z equals 13. Now let's add these two equations together, and we'll get a new equation. So 3x plus 2x is 5x. 3y plus negative 3y is 0, so those cancel out. And then negative 3z plus 2z is just negative z. And all of that equals negative 27 plus 13 is going to be, is that negative 14? Negative 14. That's right. Okay, so this is our first new equation. Now let's do this whole process again. We're going to actually try to fit it in right here. We're going to do this whole process again with the first equation and the last equation. So we see if we multiply that first equation by 5, that we can cancel the y's again with the first equation and the last equation. So let's do that. We're going to multiply the top equation by 5. So we'll get 5x plus 5y minus 5z equals negative 45. 5 times 9 is 45. Okay, now we'll add to that the third equation, which is just 3x minus 5y minus 6z equals negative 15. Okay, so let's add these two equations together, and we'll get 8x, the y's cancel, negative 11z equals negative 60. Okay, so now we have two equations with two unknowns, and we're actually going to try to do this process one more time. In this case, let's try to eliminate our z's. So we see, and what we can do here actually is I'm going to take this equation right here and I'm going to move it right over here. Okay, so that we can see both of those equations together. So now if we multiply that top equation, now in green, if we multiply our top equation there by a negative 11, then we'll get a positive 11z on the top and a negative 11z on the bottom, so they should cancel. So that's our strategy here. All right, so again, we're doing one more elimination with our two new equations that we have here. So let's multiply that top equation by negative 11. So negative 11 times 5 is negative 55x. Negative 11 times negative 1 is positive 11z. And negative 11 times negative 14 is 154. Okay, now we can take these two equations, so we can take this equation and this equation, and we can add them together. And you can see that our z's will cancel. So 8x plus negative 55, negative 55 plus 8 gives us a negative 47x. The 11s cancel out, and negative 60 plus 154 equals 94. We can now divide by negative 47, and we get x equals negative 2. Okay. Now we can take that answer for negative 2 for x, and we can substitute that into one of these equations up here, one of the two green equations here, and we could solve for z. I'm thinking we should substitute it maybe into this top equation right here. So that looks like it might be pretty easy to solve for z, so let's do that. I'm going to move over to this side over here to work this out. So we'll have 5 times x, which is negative 2, minus z equals negative 14. 5 times negative 2 is negative 10. We can add the 10 to the right, and we'll get negative 4. And then we can divide by negative 1 to get z equals 4. Now we can take our values for x and z and substitute them into one of our original equations. It looks like this equation right here, let's change colors again. Looks like this equation right here may be the easiest one to solve. So let's substitute our values of x and z into that equation and see what we get. So we'll have x, which is negative 2, y, which we don't know yet, minus z, which in this case is 4, equals negative 9. Okay, so let's go ahead and solve this equation. Negative 2 minus 4 is going to be negative 6. We can add the 6 to the right, and we'll get negative 3. So there we go. X equals negative 2, y equals negative 3, and z equals 4. So we solved for all of our unknowns there. And just to recap kind of our strategy here, we did one elimination right here, okay? We did one elimination right there, and we were trying to figure out what our z, or we were trying to eliminate the y in this case. So we chose two of our equations on the right. In this case, we chose these two, right? And we did that elimination. Then we repeated the process right here with the first equation and the third equation, okay? And again, we eliminated our y's. So we got two new equations right here by doing those two eliminations. We then did a third elimination to eliminate the z's, and when we did that, so we multiplied by negative 11 to get these two equations, and we added them together to do our third elimination, and we got this equation, where we were able to easily solve for x. Then we took our value of x, and we substituted it up into this equation, so that we could figure out z. Then we took our values of x and z and substituted them into this equation to figure out y. But anyway, guys, that is how to solve a system of 3 equations with 3 unknowns using elimination. I hope you enjoyed the video. If you did, leave a like, and I will see you in the next video. Leave any comments in the comment section if you have any questions, and I will get back with you. Thanks, guys, for watching.